A ball is shot from the ground straight up into the air with initial velocity 40 feet per second. Assuming that the air resistance can be ignored, how high does it go? Ah. Well, here we have to know the physics relationship. We have S, which stands for position. I don't know why we use S for position. V, which stands for velocity. And A, which stands for acceleration in physics of objects. So this is derivative. The derivative of position is velocity, and the derivative of velocity is acceleration. So then vice versa, the antiderivative of acceleration goes to velocity, and the opposite derivative of velocity goes back to position. So where are we at? Well, um, they're telling us down here, assume the acceleration due to gravity is 32 feet per second squared. That's acceleration. So we'll start there. Acceleration. And by the way, that's got to be negative. You got to remember that's negative. Why? Because it's down, right? The Earth pulls us down. Gravity pulls us down, negative 32. And that's what it really is. The Earth pulls down in all objects with a gravitational pull of 32 feet per second squared. In metric units, it's 9.8 meters per second squared. Anyway, we're doing English units, feet per second squared. So minus 32, there's acceleration. I want to back to velocity now. So I'm going to go, okay, I'm going to go anti, right? To go from acceleration up to velocity, I got to do an anti. So I'll go, okay, velocity. What's that going to be? I got to do the anti of that. What's the anti of minus 32? Well, it's minus 32t. Why? Well, because the derivative of minus 32t would go back to minus 32. So this must be the anti. Plus constant number 1. There could be any constant there because the derivative of a constant would just go back to 0. So any constant number that doesn't have a letter could be there. All right, so we got the velocity equation. So now what are we going to do with that? Well, they tell us the initial velocity is 40. What does that mean? That means the velocity at time 0 is 40. Initial. Initial means time 0. So that means V of 0 is, that's 0 plus C1, and that's 40. So that means C1 is 40. So that means now we have the velocity equation. It's minus 32t plus 40 C1. There we go. So we've got the velocity equation. So now we started with the acceleration equation. So now they're asking how high does it go? How high does it go? Okay, well, high is position. So we're at velocity now, we got to antiderivative back to position. So it's another anti-time. Antiderivative to the position. That's a funny, to the position equation, okay? So you remember how antis work, right? You have x to the n, the antiderivative. You do the opposite of the derivative. You add 1 to the power instead of subtracting 1, and you divide by that number in the front instead of multiplying by. Okay, so this is a 1 power, so I got to add 1. So bring the minus 32 down here. I'm doing the anti. Add 1, so it'll be t squared, and then divide by that. Plus, and this has got to be 40t, because that's going to be the anti, right? Why? Because you take 40t and you take the derivative, it'll go back to 40. Plus constant 2. We have another constant, because again, anytime you do an antiderivative step, you bring in a constant, because there could be any number here without a letter, any constant number that doesn't have t, the derivative would go back to 0, so it could be any number there. So now, what am I going to do with that? Well, the ball is shot from the ground. So that means the position at time 0 is 0. At time 0, the height, oops, that's how high the ball is. The position is at 0. I'll write the word height because that just looks weird. The height is 0. At time 0, it's shot from the ground. No, they started up into the air, so it started from the ground. So that means the position at time 0, which is 0 plus 0 plus C2 is 0. So C2 is 0. All right, so now we have the position equation. This is minus 16 t squared plus 40t, and we don't see 2 is just 0, so it's gone. So there's the position equation at any time. All right, so now what do we want to do? We want to find the position. How high does it go? Meaning the highest height. So find the highest position. In other words, maximize S. Find the maximum S. How do you maximize an equation? You take the derivative. So I'm going to say, okay, the derivative and set it equals 0. We'll bring this on down. Minus 32t to the first plus 40. Right, that one power comes down, subtract 1, it's gone. And then set that equal to 0. That's how we maximize something. Find the highest position. We take the derivative, set equals 0. So bounce that over. So minus 32t is minus 40. Divided by minus 32. And so t, bring that down here. T equals, let me see, divided by 8. It's like going to be positive. 2 negatives make positive. 5, 4. It's going to be 1. You can do it on decimals, 1.25 decimal. All right, so that's the time when it hits maximum height. But they asked not the time, not when it happens, but how high does it go? So at t equals 1.25 seconds, it reaches its max height. So what is that height? What is that height? We go back to the position equation right here. That's the position at any time t. Minus 16t squared plus 40t, right? Yeah, there we go. That's position any time. So now plug in, we're going to plug in 1.25. Found out how high it is, about 1.25 seconds. All right, let's hit the buttons on decimals. Minus 16 times 1.25 squared. Oops. Squared. Plus 40 times 1.25. 25. So it is 25 feet up. That's the highest it goes. And that's the correct answer. So that's interesting, isn't it? We can just take a ball, shot up from the ground. We know the initial velocity, like a cannon or something that, any kind of thing where you know the starting velocity. We know the maximum. We were able to calculate how high that's going to go just by knowing the starting velocity and using some physics and some calculus. So, and we did it by anti-derivatives. Started with acceleration, went back to velocity, then went to position. Then we had to maximize on the highest position, maximize the position equation, take the derivative so it equals 0. Found that it's going to happen at 1.25 seconds. Then plug in 1.25 seconds to the position equation. At that time, it's at 25 feet up. There we go.